Let's clear up a common mix-up. What you see in sidewalks and skyscrapers isn't cement, it's concrete. Cement is just one ingredient, like flour in a cake. You wouldn't call a cake flour, right? Cement is the binding agent, the glue, but concrete is the final product. The most common cement is ordinary Portland cement, named after a British stonemason's inspiration from Portland stone in England. Cement is a fine powder, but it only becomes useful when mixed with water, triggering a chemical reaction called hydration. This reaction forms a paste that binds sand and gravel into concrete, a rock-hard mass. So you buy cement, but you make concrete. Understanding this difference is key to appreciating how our world is built. We'll follow cement's journey from quarry to the structures that shape our cities. It's a story of chemistry, brute force, and transformation. And it all starts with digging rocks out of the ground. Cement's story begins in a quarry, where limestone and clay are carefully selected for their chemistry. Extraction is no gentle task. Explosives blast the rock loose, and massive loaders haul it away. The rock is crushed down to fist-sized pieces by powerful machines. Conveyor belts move the material to be proportioned. This is a precise recipe, not a random mix. Technicians monitor the chemical makeup, sometimes adding iron ore or sand to perfect the blend. The mix heads to a grinding mill, a giant steel drum filled with heavy balls that pulverize the rock into a fine powder called raw meal. This powder must be ultra-fine for the next stage. The process is loud, dusty, and massive in scale. Now, the raw meal is ready for its most dramatic transformation, the kiln. Let's turn up the heat. The raw meal enters the preheater tower. Hot gases begin heating it to 800 degrees Celsius, starting a process called calcination. Then it drops into the rotary kiln, a huge rotating steel tube lined with fire brick. At the kiln's lower end, a roaring flame pushes temperatures to 1,450 degrees Celsius, hotter than lava. Here, minerals fuse and form marble-sized nodules called clinker. Every variable, temperature, rotation, airflow, is tightly controlled for quality. The clinker exits the kiln red hot and is rapidly cooled with blasts of air. This quick cooling locks in the right chemical structure for strong cement. Even the hot air is recycled to save energy. The result, hard, lumpy clinker, ready for its final transformation. The journey from rock to clinker is a feat of chemistry and engineering. Next, we turn clinker into the powder we know as cement. Clinker isn't cement yet, it needs to be ground into a fine powder. In the finish mill, clinker is mixed with a small amount of gypsum, which controls how fast cement sets. Without gypsum, cement would harden almost instantly, impossible for construction. Sometimes additives like fly ash or slag are included for special properties. Heavy steel balls grind everything to a powder finer than a human hair. Fineness is crucial for strength and workability. Quality control is constant. Samples are tested at every stage. Only after passing strict tests is the powder called cement. It's stored in silos, ready to be shipped out. Now, it's time to make concrete. Cement is just the binder. Concrete is mostly sand, gravel, and water. Aggregates give concrete its mass and strength, while cement paste binds it all together. The water-to-cement ratio is critical. Too much water weakens concrete, too little makes it unworkable. Engineers design the mix for each project's needs. Chemical admixtures, like plasticizers, retarders, or accelerators, fine-tune the mix for flow, setting time, or durability. Ingredients are precisely batched, usually by computer, and loaded into a mixer truck. The rotating drum blends everything into a uniform, workable mix. The truck delivers fresh concrete to the job site, ready to pour. Every batch is tailored for its purpose, from patios to skyscrapers. The right recipe means strong, lasting structures, but the process isn't done yet. Curing is critical. At the site, wet concrete is poured into forms and compacted to remove air pockets. Workers level and finish the surface, but the real magic is in curing. Curing keeps concrete moist and at the right temperature so hydration continues. If it dries too fast, it loses strength and cracks. Methods include covering with plastic, spraying with curing compounds, or keeping it wet. Curing can last days or weeks depending on the project. Proper curing makes concrete stronger and more durable. Concrete keeps gaining strength for months after it hardens. From quarry to cured slab, cement and concrete shape our world. They're the backbone of our cities and infrastructure. That's how dust and rock become the foundation of modern life.